You're probably using windows, icons, menus, and a pointer right now to watch this video. Maybe you clicked a thumbnail, scrolled through your feed, opened YouTube in a browser window. This is WIMP. It's been around for over 40 years and it's become the default way most people interface with a computer. The graphical user interface first took shape at Xerox PARC in the early 70s with the Alto. It was one of the first systems built entirely around a bitmap display and a mouse. When Apple engineers saw the Alto, they recognized its potential and refined those ideas into the Macintosh released in 1984. The Mac brought the desktop metaphor into everyday use. These metaphors leveraged pre-existing mental models. If you understood a physical office, you understood the digital one. That familiarity made computers accessible to millions of people. Before GUIs, using a computer meant memorizing and recalling specific commands. You needed the exact syntax to perform even simple actions. That placed a higher cognitive load on users. WIMP changed this by shifting the burden from recall to recognition. Instead of remembering what to type, users could recognize commands in visible menus. Instead of describing what they wanted, they could select, drag, and resize objects directly and see immediate feedback. This is called direct manipulation. For users, this produced clarity and a sense of control. They could see what was happening, understand it, and undo mistakes without penalty. Now, WIMP is fast and precise, but a lot of work we do today doesn't resemble a tidy desktop. Information is fragmented, workflows stretch across apps and services, and we switch context constantly. The original desktop metaphor can struggle with tasks that have no real physical equivalent. This is not a new finding. In the 90s, researchers felt that WIMP will reach a plateau. They started exploring what might come next. Ideas included 3D file systems, gesture recognition, and pen-based systems. They were ambitious, but none of them reached mainstream adoption. Three things held them back. The technology of the time lacked the accuracy and reliability needed. Many of the alternatives did not solve real problems better than WIMP. And there was no compelling force pulling users away from what already worked. The existing metaphor was good enough. When large language models became widely accessible, conversation was pushed as the next big shift. Instead of learning the machine's logic, the machine would learn yours. This is intent-based outcome specification. You tell the user what result you want, and the system decides how to achieve it. This reverses the relationship that defined WIMP, where the user needed to know what the computer could do and where features lived. With AI, the computer needs to understand what the user intends to do. As AI systems become more capable of understanding intent, generating content, and taking autonomous action, the constraints of the WIMP model become more apparent. The constraints come down to the fact that it forces us to communicate with machines through a narrower medium. We're multimodal creatures who naturally speak, gesture, and gaze simultaneously. Yet WIMP funnels all that intent into a single stream of 2D coordinates where you point, click, and type. However, conversation alone has not been enough. This becomes obvious when traditional apps try to bolt AI on top of existing workflows. Microsoft's Copilot rollout is a good example. The idea of a deeper system integration made sense, but the implementation frequently interrupted the task at hand. A sidebar appears in many applications, offering to do tasks like rewrite or summarize content, but the design often pulled focus away from work. It also raised concerns about how much data these assistants collect, since they need context to perform well. Now, language is a flexible medium, but it's also ambiguous. It's not ideal for tasks that require precise control. A color picker, for example, is still faster and more accurate than describing a shade in words or sentences. A set of checkboxes still work better than trying to explain a complex filter. Jacob Nielsen argues that effective AI interfaces will be hybrid, combining intent-based interaction with graphical controls. GUIs show people what is possible. They make capabilities visible, which reduces cognitive effort. Asking users to articulate everything they want increases the effort again. This brings us to agentic AI, which is now being positioned in some circles as another major direction. Rather than tools that wait for instructions, agentic systems pursue goals on your behalf. They break problems into steps, call the relevant tools, interpret results, and stitch everything together. Your role shifts from operator to supervisor. When the design is thoughtful, this can be powerful. Coding tools like Claude Code help navigate code bases, surface context, and assist with debugging. Perplexity's Comet browser integrates AI agents directly into web navigation. It can understand page context, execute multi-step workflows across tabs, and interact with web applications on the user's behalf. But autonomy introduces risk. Once a system acts on your behalf, trust becomes essential. And trust collapses quickly when the design is unclear. Microsoft's Recall feature illustrates this. It was presented as a photographic memory for your PC, capturing screenshots periodically so AI could understand context. The way the data was stored raised security concerns and created uncertainty about what exactly was being captured. Screenshots could contain sensitive information. Microsoft later made it opt-in and added encryption, but the initial impression left many users uneasy. The Humane pin and the Rabbit R1 both positioned themselves as new ways to interact with AI, but neither solved a meaningful problem. Humane removed the screen without providing enough intelligence or reliability to compensate for it. Rabbit wrapped a simple voice assistant inside an unusual device and implied that it would run apps for you, which it never did in any robust way. Both products aimed for a bold future, but they asked users to give up proven workflows without offering better ones. None of this means an AI-focused device is doomed by default, though. It means that execution matters. OpenAI acquired I/O, a hardware startup founded by Johnny Ive. The potential is interesting, but potential alone does not guarantee design coherence. A team of talented people does not automatically produce a product that fits into real life well. The Humane pin was also led by ex-Apple employees, yet the fundamentals were just not there. A clearer direction is emerging in ambient and spatial computing. These areas are not about removing screens entirely. They're more about embedding computing within your environment rather than confining it to a single screen. Google's Project Astra aims to move in this direction. Headsets like Apple Vision Pro or Meta Quest place Windows not on a monitor but inside your physical environment. Apps become objects arranged in your space, and the system receives input from your eyes, hands, and surroundings. These technologies give systems more context to work with. Gaze, motion, and spatial layout become signals. This allows the system to understand your environment in a way that WIMP could not. Now, how does this concept mature to give a lot more value to users? Let's say a product designer wearing a spatial headset has some sketches placed on his desk. He looks at the sketches and says, "Generate 3 concepts for me for a speaker based on these drawings for our brand guidelines." The system sees the sketches in the room, retrieves the guidelines from company files, and produces the concepts directly in his workspace. The models appear around him. He walks around, examines proportions physically, and asks the system to explore variations. The AI updates the geometry and brings up a custom interface tailored to the request. The designer can override these decisions anytime he wants, switch to manual controls, or continue by describing what he wants next. The key shift is not a prettier render, it's the continuity. Sketch interpretation, spatial interaction, on-demand UI generation, and reasoning operate in one coherent environment. There's no switching tools or breaking the flow. The system understands context and intent, while the designer moves naturally between conversation, hand motion, and direct manipulation. If there is a pattern here, it's that every successful interface paradigm has reduced friction. WIMP made complex computers accessible by replacing command recall with visual recognition. Conversation made AI accessible by letting users express intent in natural language. The next shift will only succeed if it makes intent easier to express and results easier to control. Poorly designed systems, even if technically impressive, collapse under their own weight. Well-designed ones feel obvious once you use them, on the other hand. The paradigm that succeeds won't be the most technically sophisticated, it'll be the most human-centered. WIMP dominates because it made complex technology cognitively accessible. The next shift will succeed for the exact same reason.